presentation, The Future of Flatpak by Sebastian Wick.
Thank you. All right, so this talk is going to be about Flatpak and about what we want to do with it in the future, how we can proceed there, and also kind of a big outlook into the more distant future, what we could do there. But like mainly about the things that we can still improve and should improve. Because like it turns out that like Flatpak is doing great. Like there's a lot of Flatpak applications out there nowadays. There are new ones being added all the time. FlatHub is doing really great. More and more applications are there. Really good ones. More and more of them are getting published by the developers. We want to start reinstalling Flatpaks on distributions. That is something that is happening on multiple distributions. Like Flatpak is kind of looking to work really well and to be doing really great. We are like developing the systems around it. Like we are adding more and more portals, and it looks like everything is great. But like, is it like? Are there no issues here? Like, Flatpak itself, if you look at the project, you will notice that it's not being actively developed anymore, I would say. What's basically happening is that there's a bunch of people who will maintain the code base, who will like fix security issues, who will, you know, do all the work that's required to keep things going. But like bigger like changes are not really happening anymore. Like there's not much going on in terms of like new feature development and like kind of restructurings or anything like that. There's a bunch of like merge requests or like pull requests, it's GitHub, but a bunch of them just there, and like no one feels responsible for reviewing them. No one feels responsible for like making sure that things are, you know, being reviewed and merged, and yeah, that is kind of problematic. And the reason for that is probably that some key people have kind of left the project. Like, for example, Alexander Larsen, who created Flatpak, is not around anymore doing work on Flatpak, as basically not at all anymore, but every now and then he can become on it if it's necessary, and that is kind of what has been the reason why Flatpak continues to not rot away. Yeah, but the fact that it's hard to, you know, to create merge requests, get your stuff reviewed, and get feedback from someone who knows the code base well, that has always like some knock-on effects. Like if you are motivated and you think that like I can do this, I can change Flatpak, I can improve it, then like how do you get started? Like what is it that you should do? Because if you're doing some changes and then like you have to wait for a few months for someone to like say something, and then like wait another few months until like another review, like this really is not a great way to get someone up to speed, and it's like it's not a great situation to be in. And basically what this means that like if you lose like some key people, then a project can really go like stagnant really fast, and I think that has kind of happened with Flatpak, unfortunately. But maybe all of that is fine. Like maybe I'm like complaining about something here that is like not actually like much of an issue. Like maybe all of this is fine because just like Flatpak is stable now. I find that a really interesting argument because there must be some truth to it. We're all using Flatpak, right? Like we all are using Flatpak and it works. Like there are always things that are not working perfectly, but like overall it's really stable. It does its job, and we just use it and don't think about it much. So in that sense, I think we're like also at a good spot. But that also leads to like a question of like how can you still make meaningful contributions, and how can you meaningfully like push forward Flatpak? And I think that is kind of what I've been thinking about for quite some time now, because you're kind of living with constraints that you don't have the opportunity to just go and change Flatpak a whole lot. So one of the things that that has been happening at Red Hat is that we want to allow Flatpaks to be pre-installed on installation, and that means that we put in some resources there. So basically, the Flatpaks should be part of the base OS instead of like RPMs in that case. The way this should work is basically that like the distro or the admin like they configure a bunch of, like there's a bunch of config files basically, and that is enough to describe what applications you want to have installed, and then it goes and like if you call Flatpak pre-install, it will just make sure that those things are installed. This has been implemented by Caleb Lambert and Owen Taylor, and at some point I also joined in and did some work on this. It is now like being through the hands of a whole bunch of people, and it's, I would say, pretty well, even well-tested code. It's something that we are doing for RHEL 10, so we should be reasonably sure that this is actually working. But it's sitting there in a pull request currently, and has been for quite a while. But we hope that this is one of the features we can land, one of the bigger changes, I guess. Another thing that has kind of been happening now over like some years is that while Flatpak itself uses OS tree, like both on the server side and like on the clients, like there's an OS tree repo on the client, and then we pull down like the OS tree stuff, and it is in an OS tree repo on the client again, and then that's the thing that we are using to build the thing we are mounting inside the runtime. What has been happening is that like Flatpak has been kind of not moving away, but also additionally adding like support for OCI things, whereas OCI stands for like it's like the standard container format that like all the cloud people are using, and like Botman and all the tools. So basically, OS tree has been in some ways a success in the sense that it's working well, but also has been a problem because it suffers basically from the same problem as Flatpak here, in the sense that like it's not really maintained anymore, or not maintained but not really developed anymore. And there are a few issues. For example, FlatHub is running into like issues with like having a single big OS tree repo that they have to manage, and it's not great. And on the so kind of getting rid of OS tree on the distribution side and on the transport side is something that has been on the radar for some time now. The same thing with like building applications. Like we use Flatpak Builder, and then maybe like what's it called again? Like the well, some other tool. But essentially, like it's a very narrow set of tools that we have to like build Flatpaks, because it turns out that we have like very bespoke tooling for this, instead of like using the OCI stuff, which like has a whole range of tools that you can use at any point in time, and they all are developed by people other than us, which means we don't actually have to do some work here if you just embrace this. So that is the other thing that was kind of happening, and has been developed by Owen Taylor mostly, I think. And I think that this push will also continue. Like it's likely that we will continue like pushing like the transport and the server side in this direction. I should have looked at my slides. One of the other things that was happening around the container, like the container world, is that they added support for what's called ZSTD chunked, which is like a transport which now also supports like file level deduplication. So when you know that there's only a file that changed, you can just pull that file from the server instead of like having to pull the entire OCI layer, which has like historically been a kind of an issue, but that also kind of, yeah, it basically gives us the same efficiency that OS3 has given us historically. And there are also some few pull requests around which would improve the situation here and add new features, but again, like, it's hard to get things merged in Flatpak, so it's just sitting there currently. We are adding kind of features to narrow down the sandboxes. For example, we recently added, I mean, there's mount certain things that that are usually a sandbox escape, but some applications still need it to function at all. So we choose to like allow the applications to kind of break out of the sandbox. But we have been trying to tighten the sandbox in the sense, for example, we have the device all permission, which just mounts basically /dev in the runtime. And now we have like device input permission, which is only mounting like dev input. That kind of, it's good in the sense that it's removing all this, like it's narrowing down like the permissions. But the problem that we have now is that if we add something to Flatpak and a Flatpak application wants to use the new feature, they have to rely on the Flatpak that is shipped to all the users to actually ship the new feature. And if you don't have that, you can't really change the Flatpak. So it makes it really hard for applications to like depend on new things that are in Flatpak. So we kind of need a way to describe the situation where the application wants to still work with the old permissions, but if the Flatpak is new enough, it should only use the new permissions. So we kind of came up with a system where you kind of can remove permissions. Like in this case, it gives us the device all and device input permissions, but then says that the device all permissions should be removed if Flatpak supports like the input device thing. This is also like not a new problem. We had this before with Wayland and X11 in the sense that like if a Wayland socket exists, you basically don't want the X11 socket to get mounted instead. So this is basically a generalization of that mechanism, and we can kind of use it for all kinds of new things. And we also use this, for example, now that we have a USB portal. Same issue there, like a new portal, if it's available, applications should use it, but if the portal is not shipped on the user's machine, like you can't depend on it, so you have to express the same thing. So in general, we have kind of to solve this issue of like backwards compatibility for applications, and there's again pull request for this, and it's just also just sitting there. So another thing I wanted to kind of improve on Flatpak is the whole story around like authentication. It's kind of a bigger story and not just very Flatpak specific, but in general it turned out that we have kind of trouble identifying processes as applications. Like you can like query a bunch of things from like proc and proc-pit or whatever, and that usually gives you like some information, but like none of that is actually useful to like properly authenticate an application. So what's currently happening is that Flatpak like creates a bit of metadata for every instance that we are running outside of the system, and then like inside the sandbox there is a file in the root directory. So when you then look up like the proc-pit root Flatpak info file, it will tell you, okay, this is a certain application, and it and then you can from there on continue like querying other things, like I don't know, the desktop file, whatever you want basically. And this has worked, but it kind of prevents a bunch of things, and it's not very generic in the sense that it's like a Flatpak, like it's a Flatpak specific thing. So Yeah, it's not perfect. But what has also been happening is that we
It's currently kind of in a bad state is like audio support.
if you have an application that supports like putting stuff out on your speakers, it turns out like the application can also like capture your microphone. That's not great. That is really not good. But it basically boils down to the fact that we are running pulse audio. Like everything in the sandbox is pulse audio. There's no pipewire socket in there. We do have some portals which hand out connections to pipewire, but like the socket itself does not get mounted, and instead everything is pulse audio. And pulse audio just simply doesn't like differentiate between what is a microphone and the speaker, and it just gives you access to everything. Issue because we would like if you just have access to the raw pipewire socket, you get the same access that like like the full access to pipewire, but pipewire itself has also policies about like yeah, it has a policy configuration thing that you can use to restrict it. So together with the C group things where we can easily identify applications, we can also like in Flatpak tell pipewire that we want to on a certain C group path that we want to restrict it to only audio output, and that would mean that by default the pipewire socket inside Flatpak then only supports audio output, and we can use portals to then additionally tell it to yeah, to expose more nodes on this pipewire on the socket on a certain C group path, and with that we kind of can yeah, I hope that that way can be used to solve basically the whole issue with audio inside Flatpak. One more point which has been historically been a bit of a pain point is that nested sandboxing doesn't work in Flatpak, which means that you can't, for example, run bubble wrap inside Flatpak. And for example, browsers make heavy use of like this kind of sandboxing. They really like to put their their tabs into their own sandboxes, because it turns out that if one of those tabs like is running some code that manages to like exploit and break out of the process there, at least it's like contained and doesn't spread to the rest of the browser. So in that sense, it's a really like important security measurement from the browser vendors here, but we do not support it in Flatpak. So what has been happening instead is that we have this kind of concept of a site sandbox, where instead of like using the kernel tools to create a sandbox, we instead have a session service running, and applications can just call to that, and that will spawn another basically Flatpak instance, which again runs in a sandbox and can even be restricted further. So in that sense, that is a solution to the problem, but it is also kind of fragile. There are issues with it that have existed for quite some time, and there's no one really sure how to solve them properly. So ideally, we would just support nested namespacing and nested sandboxes. it's turned off currently because of basically two reasons. One is that for a long time, it wasn't really like a good idea to expose user namespacing because it kind of exposed a big kernel API to like user space that could be exploited. Like it has historically not been a very good user namespacing has had problems because they were going from a kind of if you're root, you are allowed to do everything model towards if you're root, you're only root in this specific namespace, and that always like going this way with a permission model is always like painful because you have to make sure that every path is actually working properly. So there has been issues, but nowadays it's kind of a really well tested and like much used interface, so I don't think it's much of a good argument anymore. But the other thing is more interesting, and that is that like to authenticate Flatpak applications, we had to look up a file in the root of the Mount sandbox, Mount namespace. So, and that is exactly the thing that I would want to replace with C groups here. And that means that we do not have this kind of restriction anymore, and we could simply turn on nested sandboxes again. Like it's pretty much just blocked with a what is it again, like a seccomp filter, and we could remove the filter after all of this work is done and get nested sandboxing again. Yeah, slides. It also like means that we can drop like the whole site sandboxing mechanism, which is great. Dropping code is always good, especially if we can just replace it with like code that other people have to maintain, in this case the kernel. There's a whole other thing that we currently use in Flatpak that is kind of crucial to how everything works, but like a lot of people are not aware of, and that is like that we have a kind of there's a dbus proxy inside every like Flatpak instance that we have. It's not exactly in the same sandbox, it's just on the side basically. It's a kind of a namespacing trick to do things right, but the gist of it is that applications don't talk directly to the dbus broker on the system. Instead, they're talking to the proxy. And what happens is that basically Flatpak run, it sets up some filters for the proxy that it will then apply. And what happens here is that we have like kind of a deny all situation where like no connections are allowed, and then we add certain connections that are allowed and which are exposed by default. And one of those by default allowed connections is to the portals, and that is why the whole thing works in the first place. Also, just a side note here, that also means that applications can't talk with other applications over dbus, but in general, like that is not really true. Like applications can talk with other applications, just not via dbus. Like for example, the network namespace is not shared currently, which means you can use like HTTP or whatever. There are like thousands of side channels that you could use if you wanted to. Like there's ways for applications to talk with each other if they wanted to, and there's basically no way for us to prevent that. So this is really about making sure that like the services that we have that don't really understand that there is like another, that there is some sandbox applications that shouldn't maybe have access to something, are avoiding, don't get exposed to applications. But like a pretty obvious thing here, like why does dbus proxy exist? I mean, it basically exists because the feature is not in the broker itself. There has been some plans for a long time to move the filtering to the brokers, but it never really materialized. The first concept of this was called Containers 1, and the problem with all of this is that that it wasn't really clear how to authenticate applications, but I think, again, with the C group thing, it becomes kind of easier because we can just use the C group path as like a identification thing, and then have policies which apply to a certain path, and then like on a subpath of it, we only have like policies which are stricter than that. So it gives us kind of a natural, nice way of doing the whole filtering thing in the on a global like broker level. And I've started working on CBus and BusD a bit already for kind of related things, but I think that's a good way to prototype everything and see if it's actually working in practice, because like it's not, let's put it this way, it's not like the old and clunky C implementation of the dbus broker, and instead the Rust implementation that is actually like understandable and like, yeah. So I'm gonna try to work on this stuff more in the future, because I think it could really improve things. It also means that we can get like a more dynamic policy system if we wanted to. Currently, everything is set up when Flatpak run is being executed, which means that you get a policy, you have to define it up front, but we could like, for example, say that like if an application announces that it wants a service to be exposed to other applications, like we could have policy in the broker that would allow for this, whereas like other like normal dbus services which are exposed, normal dbus services will not get exposed to other apps by default still. Like it opens up like the basically the policies to be more dynamic, and it also just removes a bit of the kind of path that messages go through, because it's kind of almost a bit insane like how many context switches there are nowadays in like a simple like portal call, because it goes like from the app to the proxy, from the proxy to a broker, from a broker to a portal, from a portal to a broker, back to the back end, to the broker, to a portal, to the broker, proxy, and app. This is horrible. Like all context switches. Like there's no reason for things to be that bad, to be honest. At least we can get rid of two things here. Like it's improvement. Another thing that is kind of ugly, and I just don't really have a good solution here, it's just pointing it out that it's something we should take a look at, is network namespacing, because we currently don't do it, and that leads to kind of awkward things. Like the most obvious here is that like all the services which expose like an abstract Unix socket or like bind anything on TCP and UDP, they all leak into sandboxes. Like you bind something on like localhost, and suddenly like all applications can just poke at it. One of the examples here I like to give is that like there's an application on FlatHub which is like the Ausweis app. It's like for your German for your German ID card, and you can authenticate yourself towards like websites of like the government. It basically just binds itself to like a TCP port on like localhost. This is accessible to all the Flatpak applications, and it's not great. This is some of the stuff that I feel like we really need to take a look at. I'm not sure if this is like directly exploitable, but at the very least, it's kind of scary. Like this should not exist. Like this should not be the case. But like I said before, like the problem is in general not applications are like communicating. The problem here is that applications are like exposing some of their functionality without understanding that they're exposing it to other applications. Like in the case here, like Ausweis app just doesn't know that like Flatpak probably like, you know, that it is exposing the service to like all other applications and not just to the web browser, which actually makes use of it. Yeah. We need to fix this. We need to create a network namespace for Flatpak. We don't really have any like networking experts around, which is kind of awkward. We really have to find a solution here. Like, I don't know. It's bad. More things that like are kind of in an awkward spot, and especially noticeable if you use NVIDIA, is that like drivers and driver updates are not great for Flatpak, because we basically build all the drivers against the runtime, and there are multiple runtime versions. it means that you kind of have a bunch of different like drivers that you have to ship. So every time, like, I don't know, there's a Misa update that goes into runtimes. I think you have to download multiple drivers, and it's in general like not very great way of doing things. There are also examples of how this like literally prevents you from running apps. Like if you assume that someone packages a game in Flatpak, which requires like Vulkan, for example, and then like they just leave the Flatpak be, like they don't update it anymore because like their game is done and they don't support it anymore, and then someone 10 years later wants to play the game, is still on the same runtime from 10 years ago, and like the Mesa version that we built in the runtime is also from 10 years ago and probably not supporting like maybe the GPU that you now have. And yeah, in general, it's not very like nice that in the prospect that you have applications which just stops working at some point is not good. Like, I don't like this. Right. It turns out that like Valve has been running into like kind of this issue because they have exactly this issue. Nowadays they're using also like some kind of like very similar to Flatpak model of running their games. What they do though is that they take the driver from the host and they try to figure out all the dependencies that it has, like the entire dependency tree of Mesa basically, and then just put that stuff into the sandbox, all the dependencies, and then they load all the dependencies into a new linker namespace, yes, and that linker namespace then just make sure that all the Mesa things get resolved correctly. And this is called like a libcapsule, but it is kind of fragile. Like it's not a perfect solution, and it's kind of hard to like make sure that it works well. So I would like to make it more simple and just statically compile all our drivers and then share them between all containers. And the only thing that you would depend on is like glibc, and you could just mount it everywhere because it's backwards compatible. Kind of an idea that I want to explore and see how it goes, because I think it would be good to solve this eventually. Yeah, and then obviously like portals exist, and they're kind of a crucial like point to the whole Flatpak story, but they're not really Flatpak problems. Like they are just, you know, portal is missing, and like application wants to do something that it can't do currently because the sandbox is too tight. So yeah, whatever we do with portals just directly improves Flatpak basically. But there are also like a bunch of portal things that we need to improve, I think. Like the document portal specifically is kind of too restrictive nowadays. It's very fine-grained, and it's great for exactly that, like sharing single files with the sandbox, it works well. But there's just some applications which have some other model of working where they have like an entire library of things they manage, whether it's like a music player or like, I don't know, like a Blender where you want to or share like the same assets with GIMP or something like that. Like you kind of want a more coarse-grained like permission model for files at some point as well. And yeah, there are some ideas, and we can actually nowadays like dynamically bind mount things into namespaces, which is amazing. So there are some possibilities of like how we could implement something like this, and I think that would vastly improve like how many sandbox holes we need to put into a lot of applications. There's also a lot of other ideas for portals. Like I think Emmanuel talked about this yesterday as well. Like there's a whole bunch of things we want to do, but we basically just don't have people doing the work. Like we need more people here, and we need more people working this stuff. Like there's for password managers, you want like some autofill kind of API so that they just generally work. Well, there's FIDO, which we want to support. We have been talking with some people about this nowadays, but like it's still not there. Like something we really have to get done because like passwords are horrible. We can nowadays, we could do the hit raw portal. There's like so many things. Like there was a talk about AI just now, and like portal would be probably perfect, so you don't have to ship like the huge models and runtimes for the models like in every application. It's a lot of you can do. And like I'm trying to make it easier to contribute to portals, and maybe we can use like libdex to make it even more, even simpler, and maybe like one of the ideas is that we can rewrite in Rust now that the tests are in a good state. Let's see. But portals are things that really impact Flatpak in general, so we should really focus on that as well. But like, assume that we have like a lot of time, and like it's 10 years in the future, and like no one is working on Flatpak anymore. Like, so what would you do with Flatpak if you can then just rewrite it? And I think that the vision where we should go there is kind of OCI for almost everything. It turns out that like doing our own things, it can be good. Like what Alex started here, like they're really good and sound like technical decisions, but it just ended up being not the thing that everyone else has, and that is kind of an issue because it means that like only a few people actually understand what it does, and we have to do everything ourselves. So doing everything OCI means that we get a lot of things for free. Like we can do OCI registries, we can do like whatever people are already doing, and it's great because it means we don't have to do that much. Like, yeah. Right. So, and if you do all OCI, then all it comes down to is like what Flatpak run has to do is just take like some OCI image that is like that exists in some local container storage, and use compose.fs to mount the whole thing, maybe put an overlay FS on top so you can get the config from the host. And it's actually not that much at this point anymore that you have to do. So kind of rethinking Flatpak with how it would work with the like modern like container tools is something that I think is worth exploring. Also, like if you wouldn't do this, like let's just do it in Rust. And I think that is basically, yeah. So yes, exactly. What does the future of Flatpak look like? We have a lot to do. We can still do a lot without like actually touching Flatpak that much. But like, I think in the bigger picture, what we want to have is like an alignment with like what the wider like container ecosystem is doing, because it just makes everything for us much easier. Yeah, and that's it. Thank you.
Thank you very much, Sebastian. So if you have any questions in the room, please just raise your hands.
So in that scenario, we are in Flatpak next, right? And we are using OCI and whatever. How would the migration work from my currently installed Flatpak, right? Would that be like, I just need to throw that away and download them again? Or have you thought that about, or it's like too much in the future, you haven't really worried about that yet? Or?
Half-half. I think like one of the good things about Flatpak currently is that, like, for example, all of FlatHub is declarative. Like, we can just build the same, like, we have like basically the build instructions of everything. We can build OCI containers for that. So, and that's like from that point of view, like building OCI things is not an issue. So it's, I think, more of a client-side issue than how you do the whole thing, and how you like manage to figure out how to do maybe both at the same time, or like. But yes, that would be kind of an issue, and but I don't think it's a huge issue, because like for the most part you can reuse, for example, like the applications, they have their own state and their own configuration and stuff like that, and that can still be shared. And it's mostly about like storing the images itself, and then like having a tool that creates the instance from like the image. So I think that can work side by side.
So you said we should reuse as much of the wider container infrastructure as we can, but right. I think when we did that, when we tried to do the OCI and registry integration, we found that like one thing that's missing is like indexing on the registry side. Like container registries are just like you need to know where to go, and that's not the user experience you want to have in GNOME software, for example, where you want metadata and be able to search things. So what's the way forward there?
Yeah, there's a. I mean, nowadays there's a standard for like how to store non-images in OCI registries. So we can definitely like store like arbitrary things there. So we can still like store the same things that we're currently storing there. I think it's just a matter of like writing code for it and getting it merged, which is kind of the hard part here, I think. But in general, we can store whatever metadata we want in an OCI repository. Like that is possible nowadays.
So we have a question from the chats online. Is there anything concrete / planned about audio and pipe-wire socket with Flatpak / portals?
Let's see. So, I mean, it has been mostly like me talking with Vim, like the Pipewire creator. We have been talking about some of the things before, and he implemented some support for like the same thing that we did for Wayland, where some people were exposing like protocols that should not be exposed to sandbox applications, and so we had the same need for identifying things as certain applications. But I think like that is the part that we can actually skip now with C groups. Like the C group concept it seems to be sound. Like systemd started using it, so I don't think. So I think that one should work out. And from that perspective, like that is the first step to getting Pipewire like done. I think is by fixing the part about authentication. And from then on, it's mostly about adding Pipewire policy to do the right thing when it knows that it is a Flatpak instance. But I mean, I have not written this down. Like that's something that I want to do, and I probably should do soon. Yeah.
Thank you very much. If there are no more questions in the room, I think that we are done. We don't have any more questions online for sure. So thank you very much, Sebastian. We have a 7-minute break, and we'll see you again in track 1 and 2 with the next 2 presentations.
thank you.
Oh, you're welcome.
Well,
Ready? So,
哦，
说是
说习说其语，说其语。
说是 you.
Oh yeah，说
Okay,
其语。
I'll present you.
Okay, okay. Thank you. Oh. And how to present it? How how can I present it? By yeah.
Like
This is PDF. Yeah. Here. Can. Oh, I will use this. Okay. Maybe I can use this.
Another software package format.
Okay.
This will replace bad pages.
Dice online. Non chiami live streamato? Ah, ok. E che metti tutto di microfono? If there are people following us online, we are going to start in just a minute. We are trying to set up the slides.
Okay.
And hello, everyone, and welcome back from the 5-minute break that we had. We are back with our last talk for today in track 2, and we are going to continue with exploring the Kyming software package format technology of OpenKyling operating system. I'm going to let the microphone and the stage to Shuoshi Yu.
Hello, everyone. I'm Shouqi Yu from OpenKyling. It's my great honor to be here to present our work on OpenKyling and the software and the Kyming software package format. Next, I will share from the following aspects, which are part 1, current landscape and challenges, part 2, the exploration of the Kyming software package format on OpenKyling, and part 3, a look and roadmap. So I will first introduce the OpenKyling, and then I will introduce the Kyming software package format. Part 1, current landscape and challenges. Here are several evolutions of traditional package formats. They are DEB, RPM, and package build. Firstly, the band-based system, they rely on DEB. In 2025, it has improved dependency resolution algorithms to reduce installation failures from package conflicts. What's more, some dev packages now manage via Snap. Second is the Red Hat-based system. They rely on RPM format. In 2025, GNOME Software Center may phase out RPM support in favor of Flatpak. Finally, the Arch Linux-based system, they rely on pack build. It continuous running release model with ongoing updates and maintenance for package build-based packages. Here are some development of emerging package formats. They are Flatpak, Snap, and AppImage. Firstly, Flatpak in 2024, it has added support for VLAN security context protocol, and which is enhancing sandbox security and compatibilities. What's more, FlatHub downloads supports 2 billion, flagship growing user adoption. That's really remarkable. Second is Snap. In 2024, ongoing improvements to startup speed and overall performance with notable progress in desktop application responsiveness, and it has improved the auto-update mechanism with Delta updates to reduce bandwidth usage. The finally is AppImage. In 2024, major upgrades to AppImage Kit cultures, and it has enhanced efficiency in dependency resolution and packaging workflow. There are several challenges between package formats. They are compatibility, reliability, and security. Firstly, we will focus on compatibility. Complex dependency applications often rely heavily on system libraries, which are blurring the line between apps and the systems. Second is reliability. Poorly packaged apps can affect overall system stability due to unclear system and application boundaries. Finally, security. Security contains malicious code in apps, can access private data, and revealing weak security isolation. Part 2. Let's focus on the exploration of the Kali software package format on OpenKali. So, what is OpenKali? OpenKali is an open source project by the OpenAtor Foundation, and it aims to provide an AI-integrated open source operating system. It has 9 versions, and it supports 2 million users and beyond 15,000 developers. OpenKali launched Loma, the world's first RISC-V laptop, and has introduced an AI subsystem with tools like an AI framework installer, intelligent voice assistant, and LLM-powered plugins. Just like Michael just talk. And it collaborates with large model partners, including Intel and iFly Tech, building the AI PC software and hardware. What's more, OpenKali has been featured by major media outlets, including CCTV in China, the Register and South China Morning Post and Tom's Hardware. OpenKylin has several multifunctional features. It has over 108 core system components, and the immutable system architecture built using OSH technology, and it reinvents the file system, booster process, and version management. It also supports several architectures, which is x86 and ARM64 and RISC-V long arch. The welcome compository provides essential display functions. We also have AI integration. It fully supports Intel's latest MTL AI PC platform. What is important is that UK UI desktop environment, the same as KDE and GNOME. It has optimized 6 core models. It has framework and lightweight UI design. It fully designed architecture for us, faster updates, high customer and strong scalability. The last, we will talk about Kylin software via package format, which it means to build once and run anywhere, just like Flatpak and Snap and Apple Image. It has enhanced security and compatibility. So, what is Kylin software via package format? It's a new packaging solution by the OpenKylin community decided to this purpose. It clearly separates system and application layers and to reduce fragmentation across Linux distributions, and it could enhance compatibility and simplify app deployment. What's more, it supports large-scale management of existing Linux apps. It could streamline installation and updates. The right picture is just about Kylin. Kylin has several key features. They are compatibility, security, what is important, and self-executable. For compatibility, applications remain functional even after system upgrades, ensuring long-term usability and security. It supports multiple information management mechanisms to safeguard user privacy and data. The right picture is about Kylin package offline structure. We can see that the matter section is just about Kylin application information, and the bundle section is an Scratch FS file systems. So it could make a Kylin is self-executable, just like app image. So we could run directly without installation. We have 2 core technologies behind the Kylin. They are OSH, Cron, and Kylin security. OSH manages files via version-controlled modular RIPs, and it enables efficient incremental updates. What's more, Cont leverages container take for sandboxing, such as namespace and C group. It controls system calls and enforces file-ground permission rules. Yeah. See the next. Kaimin has a 3-layer runtime architecture. We could see that we have 3 apps, UKUI apps, KDE apps, and GNOME apps. UKUI apps is based on runtime UKUI, and KDE apps is based on runtime KDE, and GNOME apps is based on runtime GNOME. This runtime is all based on one base. So, thank you, Alex, and all of you for the efforts. Oh, thank you. And we will talk about overall architecture. The Kaimin could divide into three sides, which are client side, server side, and developer side. The client side installs runtime environment, and it runs application inside a sandbox. The server side is a package wrap. And in the future, we will support for security, scanning, and advanced controls. The developer side uses the same sandbox and runtime as the client. Sources code is compiled in isolation. What's more, we could the build outputs are managed and synced via OHE. So, how do I punish our application to Kaimin package wraps? That's a very simple process. First, we have the client side, and we could through client side to install, build, and toolchain environment. It contains shared libraries, and then we could build Kaimin applications. Finally, we could punish the Kaimin applications to Kaimin package wrap, just like FatHub and Snapstore. Let's take a further look at client side of Kaimin. It has 3 aspects: command parsing, Kaimin sandbox, and host system. The command parsing includes runtime parameter, application date, and sandbox parameters wrap. We could control resource sharing between Kaimin sandbox and host systems. Let's see the client-side Kaimin sandbox. There are several models of Kaimin sandbox. Kaimin application model includes components such as applications, runtime libraries, and lightweight system libraries, which is covering dynamic libraries and configuration file resources. Besides, namespace configuration model configures namespaces within the sandbox, such as mount, IPC, PID, and network. based on runtime parameters and or policies. Next is C-run configuration model. It manages physical resources constraints within the sandbox. It configures CPU, memory, and I/O usage to ensure efficiency system resource utilization. Other, we will see proxy agent model. Okay. This is our future demo video. Then I will show it. There are 4 technical processes currently. We have developed core models such as install, run, update. Besides, we have sandbox tool enhancement and application compatibility. We have also visualized build tool. We will provide a GUI-based workflow that Flatpak not provide. Oh yeah. Part 3. The future of climbing. We will see from the forest. In the future, we will build efficiency improvements. We will have cloud-based automated builder platform and speed up development and deliver of climbing pages, security enhancements. That is important. We will refine security policies and we will integrate CVE, scanning, and paging support. Yeah. We also have where ecosystem expansion. We will support multi-reps and private climbing repo deployment. We will support for XC with Windows and APK with Android applications. Yeah. Lastly, we will the performance and usability optimization. We will faster sandbox startup times and better resources utilization for apps running in sandbox environments. Thank you. I hope we will work together and you will learn from it, fundamentally it. Okay.
Faleminderit shumë. So that's the Albanian version of thank you. So I'm very happy for that. She.
Okay. Thank you.
Thank you. So this was the last presentation for today. I think it was like a perfect closing for this day because Shuoshi traveled all the way from Beijing, China to attend last, and I think you were the person that came like that had the longer trip to attend the conference. So thank you so much. We are so grateful to have you here.
Thank you too.
Thank you everyone. Thank you. Thank you, everyone. We are going to close track 1, and we are going to have the closing speech. Track 2, we are going to close track 2, and we are going to have the closing speech in track 1. See you all there.
Okay.
Great presentation.
Thank you. Wow. Okay.
Nice closing for the sandboxing packaging summit.
Oh, thank you.